Oh well, hey there, Anna, how you going? Alright, so you've given me the problem y equals sine 2x as you can see here, but I thought I'd probably explain quickly how the translations in that of a normal y equals sine x graph normally work. Now this is your normal y equals sine x graph, but you can actually have an a value, a b value, and a c value that's all going to change the way the graph looks. Now, like I said, this is a y equals sine x graph. If I have an a value, for example, out the front, what it does is it changes how far away this from the x-axis this line goes. So, for example, if this was a 2, it would go all the way up to 2, being the amplitude, come back down here, come all the way down to -2, and go like that. The c value, what that does is it essentially just moves the graph up or down. So if this was, say, +1, and this was just a was 1, for example, what it would do is it would just move the whole graph up 1, like that, coming down, going through here. It's like something like that, for example. Right, that point really should be over here a little bit more, but you kind of get the gist. Alright, and if I had a b value, what the b value does is that's going to either shorten or lengthen the period. Now this is here is a period, so it's the time it goes from the very start all the way up, back to the middle, all the way down, and then back to the start, because from here again it's just going to repeat itself. So the b value actually changes the period. Now period is equal to 2 pi on b. So your regular graph, I mean this is sine 1x, for example, the period, our b value is 1, so you get is 2 pi on 1, which is equal to 2 pi. Now all sine graphs and that, all cos graphs, all tan graphs are always going to have your pi values, so you've got 0, pi, 2 pi, 3 pi, etc. We rarely use decimal places because it's just pi is an accurate reading. Now, for example, if I change sine x to 2, like you got here, it's going to change my period. As you can see, there's no a value, that's just 1, so it's just going to go up to this height of 1 that you can see here. Oops, it's just gotten rid of it, my bad. Let's come all the way down here. So the a value is still 1, so it's just going to come to the normal a value. Let's try again. So it comes up like here, down here like that. Now the a value is normally 1, so it's going to come up to 1 there like that, and the b, and it's going to come down to -1. So that's still the same as it is. My b value, well that's 2, so that's going to affect the period. So I would write period is equal to 2 pi on b. Now my b value, as you can see here, is 2 pi, so it becomes 2 pi on 2, which therefore means it's pi. So what's going to happen is this graph is essentially just going to go like this. It's going to come up here like that, come halfway back down, and then like that, and finish by the time it gets to pi rather than 2 pi. So it's kind of like happening twice within the space of the pi. So therefore all you need to do is you need to go through and figure out whereabouts the rest of these intersections are. So if that's at pi, well that's going to be halfway. It's going to be pi on 2 because it's half of pi. And of course, between pi on 2 and pi, or half of pi and 1 pi, you've got 3/4 pi, or 3 pi on 4. And here, it's going to be 1/4 between there, between 0 and pi, so it's going to be pi on 4. And that's what you need to do. So if you sketch this graph normally, you're going to have a graph that looks like this, comes out here like that, and it's just going to go, here is our, who's going to be pi on 2, here's going to be pi, because that's our period, so halfway there it's going to come back through, and halfway between there it's going to be pi on 4, 3 pi on 4, so it comes up to the maximum height of 1 at pi on 4, down through pi on 2, minimum height at pi, 3 pi on 4, and up to pi on 4. This here is 1, and this here is -1. Now that's really rough, but hopefully it makes some more sense to you. Have a nice holidays.